We're going to take a wee look at using the cosine rule this time to find the size of an angle in a triangle. So, when we're doing this, what you'll find is we've used the sine rule to find a side and then find an angle. We've used the cosine rule to find a side, but because the transformation to use that formula to change subject to find an angle is a bit more complex, what the SQA have kindly done is they have already given that same formula already changed for you. So there's no need for you to take the original cosine rule formula and change it about. They give it to you anyway, so use it. Okay? It's quite kind of the SQA to do that. So let's take a look at the formula. So it says cos A is equal to b squared plus c squared minus a squared all over 2bc. And this is where the values of a, b and c are the sides of the triangle that's opposite capital angle A, capital angle B and capital angle C. So labelling your side is incredibly important here. So remember, if this is angle A, this will be small letter A. If this is angle B, this will be small letter B. If this is angle C, this will be small letter C. Now, what I need you to notice here, when you're working with this formula, you must pay attention to the pattern of the letters. So if I have cos A is equal to b squared plus c squared minus a squared all over 2bc, if I'm asked to find out the size of angle A, then because that's opposite side A, we're always going to be taking away the opposite side. So cos A is always going to be opposite is always going to be at the other end to where we have the minus a squared in the equation. If I was to write this in terms of cos B, for example, and I said cos B equals, then I would say it would be a squared plus c squared minus b squared all over 2ac. The letters in the middle stay the same, but the angle and the side opposite it, you have to pay attention to the location of those. In the same way, if I was to deal with finding the size of angle C, and I said cos C, that would be equal to a squared plus b squared minus c squared all over 2ab. Again, just paying attention to where angle C and side C are. And this one where angle B and side B are. Okay? So, example 10. I want to find the size of the angle that's labelled A. So let's go ahead and straight away label our sides. So this will be side A, this will be side B, and this will be side C. And always start with the formula that you're given. So the formula is cos A is equal to b squared plus c squared minus a squared all over 2bc. And let's just put those values in as we see it. So that's going to be cos A is equal to 16 squared plus 7.6 squared minus the opposite side squared. It's always minusing the opposite side from the angle that you want. Remember that. So it's minus 13.5 squared all over 2 times 16 times 7.6. Okay? I suppose another way you can remember it is the side opposite the angle you want appears once and the other two sides appear twice. The 16 and the 17, the 7.6. Okay? Just do whatever it takes for you to remember the pattern of the letters and numbers here. So cos A is equal to, and let's just plug that into the calculator. So using your fraction button is the easiest way. We all have a Casio calculator anyway. So it'd be 16 squared minus plus 7.6 squared minus 13.5 squared all over 2 times 16 times 7.6. And that'll give me 0.5 5407 483 553. Then just cos to minus 1 that. Remember to make sure that your calculator is in degrees mode for these. So shift cos that, and we get 57.3 degrees, which is our related angle. And remember, when we solve a trig equation, we always go to the cast diagram. And you'll notice something different about this. What we're dealing with here is cosines are positive, because cos A is a positive number there. So that's going to be whenever our solutions are in the all and cos quadrants. What I need you to realise this, and this is the little caveat about the cosine rule. In a triangle, the biggest angle that you can ever get is, well, you can't get 180 degrees, but you can get infinitesimally close to it. Your angles cannot go above 180 degrees, because that's the size of the sum of the three angles. So automatically, you can just forget about these answers below in the tan and cosine quadrants. You can only ever go as far as 180 degrees. So that means that your solution has to be in the first quadrant. There's no other choice for that. So I can say that angle A is going to be 57.3 degrees. Okay? Let's take a look at example 11. So, I want to find the size of angle X. So first thing I'm going to do here is I'm going to label the sides. So if this is angle X, this will be small letter X. And I'm just going to follow the alphabet. If this is angle Y, this will be small letter Y. If this is angle Z, this will be small letter Z. So always start by writing out the formula you're given, which is cos A is equal to B squared plus C squared minus A squared all over 2BC. And remember what I said, look at the pattern of your letters. You are being asked to find out the value of angle X. So it's cos X. Look at where A and A are in your original formula. That's where X and X are going to go. So Y and Z have to be in the other positions. So that would just be Y squared plus Z squared minus X squared all over 2YZ. It doesn't matter if you say Z squared plus Y squared, because you're adding them together, you get the same answer. But you must make sure that you take away the opposite side from the angle squared. That's a key thing to remember here. So now all we do is just put in the sides. So we get cos X is equal to 61 squared plus 90 squared, take away 120 squared, all over 2 times 61 times 90. So I am going to type that into my calculator first of all. So again, using my fraction button, 61 squared plus 90 squared, take away 120 squared, all over 2 times 61 times 90. And that's going to give me minus 0.23488166029. So X is going to be cos to the minus 1. Remember, we always do of the positive value. Cos to the minus 1 of positive 0.23488166029. So X is going to be 76.4 degrees, which is our related angle. So let's go to the cast diagram, because we're solving a trig equation, we always go to our cast diagram. And remember, we go back to the line that says cos x equals. Cos x equals a negative number. So where are cosines negative? They are negative in the second and third quadrants. Now remember what I said in the previous example about the size of the angles in a triangle. You cannot get anything bigger than 180 degrees. So straight away you can just forget about anything in the last two quadrants. So therefore your solution has to lie in this quadrant where it's 180 minus the angle. So that means that angle x is going to be 180 minus 76.4 degrees. So take that away from 180 and you get 103.6 degrees. Double underline your final answer just so that your examiner knows that is what you want to offer. Okay? So when we're looking at this, again, always look at your diagram as your guide. Does it make sense that the answer should be 76.4 degrees? No, it's not. Because the angle is clearly bigger than 90, so 103.6 degrees fits far easily. And that is using the cosine rule to find an angle.